Hello everyone, this is Juan Irazo. I'm a senior .NET developer here at JDK Outstanding Technologies. And today we're going to talk about solid principles, specifically in C Sharp. So, solid principles, just to start with, are set of 5 design principles that help developers write more maintainable, flexible, and scalable code. They were introduced by Robert C. Martin, someone they might know it as Uncle Bob, and formed the foundation for object orientation programming and design. Each letter in SOLID stands for a specific principle. So, on this case, there are 5 principles that we're going to go each one by one, just to see how they work, with some examples, and this would help us to do and create our APIs better and more scalable on code for future projects, right? So we're going to start with the first one, which will be single responsibility principle, or SRP, right? This is a class should have a single responsibility or purpose. If a class has more than one reason to change, it's violating the SRP. So there's an incorrect example right here, right? That's the one we have and this on this case, which is invoice. We had 3 different actions with the boy functions from the class. So I have generate invoice, send an email, and print invoice. So based on the principle, a class should have a single responsibility on purpose. This class has 3 different responsibilities, which is not following the purpose. So what could be a better approach? The best option is this one, right? To have an each specific class to get their own public void generate invoice, for example, on invoice, and on email services, send email. On print services, print invoice. So they have one single responsibility for each class. This does not mean that they only had one single method. This is just an example, but means that all methods that are related to invoice will be on this class, which that's their responsibility. For example, if I want to create a different method like recalculate invoice, this will be also inside of invoice as it is related with the class itself. This is the same for email services. In this case, email services can be used in many classes or many auctions, but there could be another notification process that could be implemented on this class. As well for print services, we have a print invoice, but we could also have another method which is called print recalculate invoice. So with this being said, this is the best example of how we can apply single responsibility, which is a single responsibility principle, right? Let's go ahead and continue with the next one, which is open close principle, or OCP. This is a class that should be open for extensions but closed for modifications. Adding new features should be done by extending the class and not by modifying it, right? So I have this invoice class on right here, and I have a method which is called calculate discount, which is receiving a parameter called customer type, right? Depending on the customer, it returns a number, right? That's the discount that they need. For example, regular, VIP, and else. So what happens if in the future I need to create new discounts for this? So I will need to go ahead and modify the original calculate discount, and it might affect my entire code. So let's say I have 3 months already working on a project using the same calculate discount method. If I go ahead and modify the same class, I will be modifying the entire code, which is not the best option. So what would be the best approach? In this case, it's doing overloads and inherit a discount interface. For example, right here, I'm creating a public interface iDiscount, which is declaring a decimal apply discount function. Then I create regular customer discount, which is a class to return what will be the discount for a regular customer. In this case, I inherit the iDiscount to access to the apply discount. So once I have access to this apply discount, I can overload this function to return different options without really modifying the original function. So for this approach, I'm not really touching the original function that is already used in other code, and I'm actually applying a new logic that will be required for my objectives, right? or for what I'm doing right now. It will be the same for VIP customer discount and inherent the function, right? The I interface, and then I applying the return for this specific VIP customer discount. So whenever I go to the invoice and I apply a plug decimal calculate discount and inherit the discount interface to access the regular process, right? This is the regular one that is on the iDiscount function. So this is a better approach whenever you have large teams and you have large amount of data that is already work and you don't want to really modify the original piece of code because it will be modifying everything else and it will be a lot of refactor on your code. So the best idea is to make modifications on extensions of for example, inherits instead of really going into the original method and making the change, right? So that's what this principle is about. Let's go ahead and continue with the next one, which is Liskov substitution principle, or called SLP. Liskov substitution principle states that subtypes must be able to replace their base types without affecting the correctness of the program. In other words, if a class B is a subclass of a class A, we should be able to replace A with B without breaking the behavior of the program. Good. Now that we have this in mind, let's see this example. I have a class which is a bird. This bird has a function, a virtual boy function, which is fly, right? So this means that every bird can fly. But what happens when you have birds that can fly, which is the example below? Public class penguin, which is inherent bird, that's true. Penguin is a bird, but unfortunately, a bird can fly. So what will happen? You will need to control and validate each specific scenarios depending on what ping on what kind of bird, and this will cost you more time and more code, right? And this will be variable, like it might be on different scenarios. Like we have, for example, some animals that can swim, or animals that can't really fly, right? Like on this example. So what could be the best approach in this? Like in order to avoid those validations inside of this penguin method, penguin class, inside of the fly method, we can go ahead and create different options. So for example, dividing the classes bird. Like for example, I have bird, right? I know that inside a bird, there's a function that's called eat, right? The bird is eating. So all birds can eat. We know that, right? But as we don't have the I flyable, so not all birds can fly, I actually not using the fly boy functions inside of the bird because we know it's not possible that all birds can fly. So I'm extracting that to a different interface, which is called iFlyable on this scenario. And then whenever I have cases like, for example, on this one, which is a sparrow, we know the sparrow is actually a bird and they can fly, right? So in here in the iFlyable, I'm accessing the boy fly function, meaning that this bird can fly. But in case of penguin, which is the error we got before, we get the penguin and we are in bird, which is true, but we're not in flyable because this bird can fly. So with this structure, you're avoiding this process to validate what birds can fly or not by splitting these functionalities like iFlyable into different interfaces that you can inherit between your classes. So it will be much easier to control the methods and actions you have inside of classes this way, instead of, for example, just creating all methods inside of one class and then inheriting this, and then you have to make validations inside of that class. You are avoiding that by doing this in structure. So that's what it's helpful for. Now let's continue with the next one, which is will be the next principle, that it's called interface segregation principle, or called ISP. Clients should not be forced to depend on an interface they don't need. Split large interfaces into smaller, more specific interface, which is a little bit similar of what we did before, but we're going to explain this on a different scenario with interfaces. Like before, it was in a scenario with classes and methods inside classes, which is what we'll call properties for that. So let's go ahead and check this example, which is I have an interface which has two functions, work and eat. But we have a class which is inherent the iWorker class. We know the robot can work, but a robot cannot eat. So this is the similar of what we got before, but in this case with interfaces. So instead of really having this method inside of this interface, what we had to do is just split them. So I'm going to create another interface for iWorkable, which will give me a function of work, and I will have another interface of iFeedable, which will give me a function for eat. So whenever I want to create new classes based on those interfaces, I can actually inherit those, right? For example, human. I know a human can work, so I'm inheriting iWorkable. I know a human can eat, so I'm actually inheriting iFeedable. In case of a robot, that's not the case, so I'm going to inherit iWorkable, only because a robot can only work. So as you can see, solid principles maintain visibility of what you can do or not. Basically on classes, as we saw before, on interfaces, and also on methods that can be modified or not depending on the complex of your code. So let's continue with this. We're about to finish. We're about to go to the last one, which is dependency inversion principle, or called DIP. So high-level models should not depend on low-level models, but should depend on abstractions, reduces coupling, and increases flexibility. So what happened here is that some scenarios where we want to use functions that we have in other methods, like let's go to the incur example just to see what we're talking about. We have email services, which is actually creating a function for send an email. So I have another class, which will be my notification service. What I do is that I actually create a new instance of this email services inside of my method to actually access into and send email function, right? Send notification to actually send the email. But in this case, you are going to create an instance directly inside of the notification class, which is not really recommended. You are creating a couple, so every time you do have a notification class, you're going to make this instance, and sometimes it will be have some redundancy. Instead of this, we had to make an abstraction with the interface injection. Let's see how it should be. Like for example, on this code, we have iMessage services, which is the interface that I actually use to access to the logic of a service. That in this case, I have my email services, which it will be inheriting the iMessage services. That means that the logic should be inside of the email services, not inside of any other classes. And my interface are only the access level from other classes, right? So every function that I have here had to be implemented into the services, so this can be efficient and work correctly. It will be the same for SMS service that we also send a message, but the difference is that it's a different type of service, with a different type of message. So let's go ahead and see this approach into the notification process. So right now in my class, I will actually create a private read-only iMessage service, which is the interface itself, not the service, the method itself where the logic is. So with this, you're creating a level of access, meaning that probably even some scenarios, some programmers will not be able to see the service, but only the interfaces. So you are creating an interface so this could be more readable and more reliable in terms of modifying services that cannot be modified. So that's the first thing. After that, you're making an injection into a constructor, making a single instance for notification. So that means that I'm going to have these message services equal my constructor service that I'm doing right now into my message service variable. So whenever I want to use it on any other method, for example, right now I'm using it on send notification, which is message service send message, and that's perfect. But I can also use it in other methods like send SMS notification or send other type of notifications and using the single message service. So with this approach, it's easier to control the access of the code and as well to avoid couples like many instances inside of a class. Instead of that, you're making an instance into a constructor, a single instance itself. So basically, that is it for the solid principles. Those are really good in case on some scenarios. Of course, you need to analyze where to use it, where you had the best approach. It might depend on what level you want to use it, but it's also good to know this, right? Sometimes it's not mandatory to use it depending on the scenario, but it will be really good you to understand how it works. So that whenever you have cases like this, like trying to see how you're going to implement your interfaces or your classes or how you're going to inject your services, this is what you need to do in terms of scalability for your future projects, right? So that is it for today. I hope you like it. If you have questions or comments, you can let us know on the comments below. Have a good one.